Today we are talking about making meaning and interpreting data. As we begin to look at data this year, it will be important to have a basic understanding of some statistical terms and how they apply to educational data. We need to use data with purpose in order to improve learning outcomes. Using data without context and interpretation will not help us build our knowledge and won't allow us to gain actionable information that leads us to continuous improvement. When looking at data, we have to remember that we have to know more than just the change in scores, up or down. Changes in scores are also affected by the number of students in the data set. Rule of thumb, always know our N size, the number of kids in our data set. This is particularly important when looking at our school and subpopulation data. In addition to knowing about our N size, we also need to understand variability or variation. The statistical term for measuring variability is standard deviation. This figure is called a bell curve, and it shows how a typical or normal distribution of student scores might look. The peak of the bell curve is the mean, or average. 68% of our student scores would be within one standard deviation of the mean, or average. 2 standard deviations away from the mean would account for roughly 95% of our student scores. Again, the standard deviation measures the variability, or the spread of the student scores around the mean value. Given a 30-point test, we could get these two data sets from two different groups of students. The mean of these two data sets is the same, 15. However, the second data set is clearly more spread out, and this will impact how we make meaning of the data. In order to determine what growth we need to be confident that the growth is statistically significant, we will need to see growth of at least 2 standard errors from the mean. Standard errors come from dividing standard deviations by the square root of the sample size, which is the number of students. Standard errors are also called confidence intervals, and these will be provided to us to assist us in setting student, class, and school-wide goals. These are some examples of how we will use our standard error data to determine meaningful goals for our schools and our students. These are based on the 95% confidence interval, or 2 standard errors. We can use the data to set grade level goals and/or cohort goals. This is a growth goal example. We need to take our standard error, provided to us with our data, and multiply 2 times for 95% confidence interval in order to know what % growth we will need to have statistically significant growth. Using data effectively will help us build a foundation of knowledge that leads to well-defined goals and solid instructional practices that will benefit all of our students. Let's dig in, ask questions, and enjoy.